good to be back. Hello and welcome back, and we are fresh back from VCF East, which was just 3 days of pure brilliance. It was just one of the most fun events I've ever been at in my life, and I did a full video on it last week, so if you haven't seen that, go check it out. But that video really only covered about 30%. The event was massive. The turnout was unbelievable, and even though I was there for all 3 days, there was a lot of things that I didn't get to see. So I'm definitely going back next year, but I don't think I'll drive. I think I'll fly. 3,400 miles round trip was just a little too much for me. But we're here back in Texas in the office, ready to get to work on some new projects, and boy, do we have a lot of stuff lined up. The Mini Centurion took a little bit of damage on its way back from VCF East, most of it to the top, and we needed to put a laminate on top of that anyways. Next to it, we have the PDP-1144, the 1183, and a deck Rainbow, all waiting for work. The genuine Centurion over here has a laundry list of things that need doing, including the printer and the Finch drive. The vacuum tube computer is calling to me, but I'm pretty unhappy with the direction it's headed in, so I think we're gonna scale it back a little bit and kind of change the design a bit to be more in line with the spirit in which it was built. So there's gonna be a lot more of it coming up as soon as I get done with the design work. And we also have this little Litton mini computer here that's really get in there and see what that rotating drum memory is like. But I'm not going to do anything on any of those today because there is a project that I have been chomping at the bit to get to, and now is the perfect time. And that is my TI-99 here. Now, this TI-99 is no stranger to the channel. We've done some pretty interesting things with it. Most notably, we got it hooked up as a terminal for the Centurion. So what needs doing on this? Well, the TI-99 here works perfectly. It needs absolutely nothing. But I modeled this entire thing on the single marketing photo that's been floating around of the original TI-99 with all of the sidecars attached to it. And, well, we're pretty close, but the 99.4A is not a 99.4. It just so happens that my good friend David hooked me up with a 99.4. But I was using a Sanyo monitor and the marketing photo wasn't, so we need to get a proper TI monitor in there, and sure enough, my friend David hooked me up with a TI color monitor as well. This is the appropriate monitor, the appropriate 99.4, and all of the appropriate sidecars. So we really need to get this thing up and going, and that is what we're gonna do today. So let's pull that 99.4 out, take a look at what makes it so unique, and see if we can breathe some life into it. And then we'll also clean up the monitor and then get the whole setup going on. This is gonna be so much fun. All right, this is a pretty rare sight to see a proper TI-99 next to a 99.4A. That's just super cool. But why is it so rare? Well, they made about 3 million of the 99.4As, but they only made around 20,000 of the 99.4s. So the 99.4 was the first 16-bit home computer ever released, and it was released in 1979. And it was epic, except for the fact that the architecture is compromised. So even though you have a 16-bit CPU in it, it can only access RAM 8 bits at a time, and that has to be doled out through the VDP or Video Display Processor. Now, there are some interesting differences between the two. The most obvious here is going to be the keyboard. This one has a weird chiclet keyboard that feels awful. This one has a very nice Alps keyboard that feels amazing. But there's also some other interesting differences that you don't quite pick up in pictures. The metal on the 99.4 is kind of a amber color, while on the 99.4A it's just pure silver. The 99.4 also has a headphone jack on the front corner here, which the 4A doesn't have. But there is one more very big difference between the two, and it's actually internal to the machine. The 99.4 uses the TMS9918 video display chip, and the 99.4A uses the TMS9918A video display chip. So that's where the A in the name TI-99 comes from. But this is more than just a simple revision. The 9918A has a lot more functionality. Most notably, it has a bitmap mode. So that means that any piece of software that uses the bitmap mode will not run on the 99.4. The 99.4 is also missing a couple of assembly instructions and some other small things. So let's pull this thing completely apart so we can clean it up fully, make sure that it looks spick and span and brand new, and then we'll try and put some power into it and see if we can get it working. We'll start by popping off the power button so we don't break it later. Then there are 6 screws on the bottom as opposed to the 7 screws of the 4A, but with those removed, the cover lifts right off, and right off the bat we can see some interesting things, like the keyboard button is wired up separately. And here's a closer look at the headphone jack. So next, let's remove the power supply. It's just 2 screws and then it lifts right out. And interestingly, the power connector has a plug in the middle of the wires as opposed to headers on the PCB. To get the motherboard and keyboard out, there are 3 screws for the motherboard and 2 screws on the keyboard, and then the whole thing kind of pops out of place. Next, let's get the RF shielding off, and we'll start by removing the 2 big clips, and then we'll remove the 2 screws holding the 2 pieces together. And interestingly, we also need to remove the screws holding the expansion shield in place. Then it pulls right up and, that's kind of dumb. TI ran the power cables to lugs on the RF shielding, and it's all soldered in place, so the lower RF shield can't be removed. All right, well, let's get the other side off, and thankfully that side is pretty easy. And here we go, a TI-99 motherboard, mostly free from its cage. All right, this is so cool to see, just again, because it's so rare. On the left here, we have the 99.4 that we just took apart. On the right, we've got a 99.4A. This is actually the spare 99.4A that I got from Runaway over at Runaway's Auspicious Travails. Thank you so much for that, Runaway. And I just pulled it apart because I wanted to see the 2 motherboards side by side, and it's really fascinating the differences between them. The biggest thing that stands out right off the bat is the TMS9901 here. This beautiful ceramic and gold pin package looks way more attractive than the kind of boring dip package over on the 99.4A. Also, over here in the top left, we've got our main culprit that's going to cause a lot of software to be incompatible. This is the TMS9918, and this is the 9918A. Now, these are socketed, and you could theoretically pop them out and switch them, but that's still not going to upgrade your 99.4. Too much stuff is reliant on this being a 9918 without the A. If we look at the RAM, the main system RAM is over here. This is also the video RAM, and this is all 4116 RAM chips, identical between the two. But right above the RAM is the video section, and it looks quite a bit different between the two of them. But for the most part, it looks very similar. It's just everything about this one feels so much like a prototype, and the 4A feels like a finished product. Now, if we move up to the power supply here, this is one that I was really kind of worried about because I don't actually have the power brick for the 4 here. I have the power brick for the 4A, but they are slightly different. The power brick for the 4 has just a slightly different AC output that comes into the power supply here. So what we're going to do first, I think, is test this power supply with the 4A power brick first, check the voltages coming out of it and see if they're kind of on point. However, before we do any of that, I gotta clean this thing up. It is filthy. We've got a lot of cleaning up to do, both of the PCB, the keyboard, and the power supply here, as well as the case itself. So I'm gonna get to work on that. We'll start by brushing off the big stuff from the power supply board, and then we'll do the same on the main board and focusing particularly on the keyboard because it was pretty gross. And speaking of the keyboard, each key will get a wipe down on all sides to make it nice and clean. Then we'll add a little oil to the keyboard stabilizer, and I'll clean up the excess after working it in and making sure it's smooth. Then a nice air hose to clean all the big stuff off of the case, and then everything will get a very nice wash with water to really clean it up. and on the top of the case there were 2 stickers. So we'll use some Goo Gone and a Bondo spreader to clean that up. And I wasn't sure of the best way to clean up the metal part of the casing, so I tried some metal polish here and it worked all right. The case was missing a rubber foot though, so a little double-sided tape and a new salvaged one will go on. And next I want to clean up the RF shielding, or the one that we could remove at least, since it had a lot of rust. But I know that it'll rust again if I don't coat it with something. I'm just not sure what's best for that. Finally, let's check the power supplies. The 4A supply is giving nice voltages even without a load on it. So let's try the 99.4 power supply with the 4A AC brick, and yeah, clean +5, +12, and -5. Power supply looks like it's going to work. The motherboard, keyboard, and case looks like it's going to clean up very nicely, so I'm about ready to give this thing a test, but I'm going to need a monitor to test it with, and for that I want to use this Texas Instruments color monitor. It does need a little bit of cleaning, not too much, it's in pretty good shape. However, I know that it works, but the color isn't quite right. And you can actually get the color really close using the color potentiometer in here, but it's so scratchy that you kind of have to try and find a sweet spot for it. Pretty much all of these potentiometers are just full of gunk and nastiness, so we need to pull the case off of it and get some contact cleaner into these potentiometers to clean them up correctly, so that way we can actually properly adjust the picture on this. Now, anytime you're working with a CRT, there is extremely dangerous voltages in there. This being a color CRT means that there's probably 15,000 to 20,000 volts in there, which is enough to not only ruin your day, but ruin the day of whoever has to take you to the hospital. And so don't play around with CRTs unless you know what you're doing. So we're going to be very careful in there. We're going to make sure that everything is discharged. We're going to get this cleaned up, and we're going to plug it into the TI-99, and we're going to give it a test. So let's get to work on this thing. There are a handful of screws on the back plate. We'll remove all of them, and then the back plate can pull right off, and danger, Will Robinson, there is high voltage in here. We'll flip the monitor onto its face, being careful to hang the power switch off the edge of the table so we don't break it. Then we'll remove the 4 screws on the sides, followed by the 4 screws on the bottom, and the outer casing then slides right off by pulling it straight up. To get to the potentiometers, I made this kind of janky extender for my contact cleaner, and it's a little hard to see, but I was able to reach down to the potentiometers themselves and get some cleaner into them. Then we'll just work the potentiometer from stop to stop to clean up the contacts inside. With those clean, let's put some power into it and see if we broke anything in the process, and yep, that's a beautiful looking filament. I think we're good. We didn't let any magic smoke out. That's good news. So the next step is to try and get all of the potentiometers into kind of the correct adjustment. But so we're not trying to troubleshoot 2 things at once. We'll do it using a known quantity, the TI-99 4A that we know is good and working. Now, there's probably going to be a little bit of a 15 kilohertz whine while I do this. I can't hear it in person, and I certainly can't hear it on the video, so I'm just going to have to try and roll it off using visual tools, but I'm not very good at that. So if there's a bit of a whine in the video, I apologize. Y'all can just go ahead and skip ahead and skip past this section. So we'll go ahead and flip the monitor on here. It's going to start warming up. We'll flip the TI-99 on here, and we should be getting a picture. Yeah, we can see that we've got a picture, but boy, does it not look right. So the color is all sorts of incorrect, first of all. So if wow, we can only really get to green there, but we also have this tint here. Oh, and that was all the way to the right. There we go. That's looking pretty close. The color's looking pretty good. Our brightness is, wow, our brightness is maxed. This is a very tired CRT, but all of the potentiometers feel very good. The contrast is pretty good, and if we play with the vertical hold, we can make it do all sorts of crazy stuff, but that's looking pretty good. We've got some ghosting going on here with the text. I don't really know how to fix that, but you know, that looks pretty decent for a very old CRT. Monitor's looking pretty good. I think it's time to put power into this 99.4 for the first time in probably 30 years. I genuinely have not tested anything off camera here, so you're gonna be experiencing it with me. If we let the magic smoke out, we'll let it out together. So we'll flip the monitor on. It's gonna start warming up, and it should be pretty much ready for a signal. So we'll go ahead and flip the power on here, and nothing. Well, it couldn't have been easy, right? And so starts the troubleshooting process. We'll start with the basics. Check the voltages, check the clocks, check the reset signal, and check for activity on the data and address lines. That all looks good, so next is diving into the manual that some legend uploaded on the internet, and, well, following the procedure isn't actually all that intuitive, though. I've been working on this for a while now, and the problem that I was having with this troubleshooting procedure that they outline in the manual here is a lot of times they just tell you to check if something is good or check for signal, and I don't know what good or even marginal would look like, so I decided to start checking backwards. We know that our CRT isn't displaying anything, so I decided to check to see if we were getting a video signal. And so if I check on the TMS9918 here, this is the video signal output out of the 9918. And you can see, I think that looks like a standard composite signal output. From here, it goes through some transistors and ultimately out to the video cable on pin 4. If I check pin 4, nothing. There's nothing there. It's totally dead. So there's a very interesting arrangement. I actually was able to find the schematics, and so I recreated the schematic for the video signal here. Coming from the VDP out, it goes through a couple of resistors into this interesting transistor combo over here. And so as I understand it, the input signal is coming into the emitter of Q200 here, which is a 3904, and it's changing the potential of the emitter in relation to the base, which is held at a constant value by this resistor divider network here. And with that emitter changing value, it's going to cause the transistor to conduct more or less, which is going to change the signal that's coming off of the collector at the top here. And then that collector is directly connected to the base of Q201, and that sends it all the way out to our pin 4 over here. And Q200 is pretty easy to check. It's right here. And so if we kick this back on and we check the emitter of Q200, well, it's a little small, but there is an input signal coming into it. I imagine the resistor network that comes up beforehand here is modifying that signal in some way. So let's check the collector now, and yeah, that's totally dead. There's nothing happening on the collector. And if there's nothing happening on the collector, then there's nothing making it to Q201, which means that there's no video signal ever making it out. So our video signal dies an unceremonious death right here at Q200. After talking with FPGA and Space on the Discord quite a lot this morning about this whole video circuit, we kind of came to the conclusion that either Q200 or Q201 were behaving incorrectly. So I replaced one, that didn't fix it. I replaced both, and now we actually get some form of life coming up on the CRT here, but it's just an empty signal. There's no data in it. So the machine is not actually booting at all still. And honestly, that wasn't that surprising. I was not expecting this to be that easy. So I was back to the flowchart diagnostic procedure that we have here from the manual, and I followed this as best as I could, and I got down to this one here, which says check pin 14 of U505 for a signal. So if we flip the power on here and check pin 14 of U505, which is right here, we can see that there's no signal there. That is just held high all the time. It's kind of dead. And so our manual here says that the probability is U505. Now, unfortunately, this one is not socketed, so I am going to have to desolder it, put a socket in there, and put a new chip in place. I do have a new one of these. This is a 74LS138. I don't think this is the actual problem, though. I think it's probably somewhere deeper in the system, maybe a 4116, or certainly hope not, but could potentially be the 9900 itself. But since the diagnostic procedure got us to this point that says U505 could potentially be bad, we'll start there and replace it first. Desoldering the IC is actually relatively easy. I just used my generic desoldering iron with a little bulb on it for sucking solder up. It works decently well, and you can find these on Amazon for like $20 to $30. And with the IC removed, we just pop in a new socket and a new 74LS138. All right, LS138 replaced. I genuinely don't think that was what was wrong, but let's go for broke anyways. We'll turn the monitor on and then flip the power switch on and see what happens. Nothing. Yep, that's the exact same type of failure mode that it was in before. Well, that's not really surprising. Back to more troubleshooting. All right, I think I'm starting to hone in on a bit of a problem here. I'm checking the address data lines on the 9918, and I'm on address data line 2, and you can see that there's some activity going on here. And address data line 7, 6, 5, 4, and 3 all look the same. But if I check address data line 1, we can see it's just stuck at a noisy high level. Now the troubleshooting diagram flowchart here says possibility 9918, and I actually have 4 different 9918s pillaged from different TI-99s over the years, and all 4 of them have the exact same line dead up here. So I'm starting to think it's not the 9918, and it's what this pin from the 9918 connects to. And if we look at this schematic here, it connects to the 4116 RAM chips. And well, I've been kind of beating around the bush on these. The 4116s are pretty notorious for going bad. And well, as much of a pain as it is, I bet it's one of those. So we'll get to work on that. I hate doing blanket replacements of one type of component. I will generally refuse to recap something simply because caps can sometimes go bad. And here, I hate the idea of removing all the 4116s because one of them might be bad or because they're notorious for going bad. I don't think all 8 of these chips are bad. I think only one of them is. But all 8 chips share the same address bus lines. And so with one chip pulling an address line high, it's almost impossible to tell which chip is actually doing that because the high value shows up on all the chips. And there might be some obvious diagnostic procedure I'm missing here, but really this was the only way I could see. So I spent a couple of hours and desoldered 128 pins across 8 ICs. Then I cleaned the board up and soldered in some new sockets. And I also sat down and modified some 4164s to act as 4116 replacements using this excellent guide I found on the internet, because I don't really expect the 4116s to survive the horrors of desoldering. All right, that was kind of tedious and not super fun, but I've got a collection of 4164s in here that are modified to work as 4116s. I actually used this same technique on a memory board for the Centurion, and it worked perfectly in that system. So I've got it all plugged back in, and I'm just gonna go for broke, because if this doesn't work, I'm running out of ideas, and I'm gonna have to take a minute to think about what the next step is. So, well, here goes nothing. We'll turn the monitor on. Let the CRT warm up for a second here. And hopefully we don't let the magic smoke out, but we'll flip the power switch on and no change. Oh, well, at least we didn't let the magic smoke out, but I was really hoping something would work here. Despite the fact that it didn't actually start up, we did get our missing line back, so we definitely had a bad 4116 in there. I don't really know which 4116 it was. TI didn't make this easy by not socketing them. But since we have that back, that's good. That means that we're making progress. So we found 2 big errors so far. The 2 3904s for our video output circuit were dead, and we had a bad 4116, but we're not there yet. We still got something else terribly wrong on this, and I'm becoming increasingly afraid that it's the 9900.
which is going to be a nightmare. And I don't want to get rid of this beautiful ceramic package anyways. So what we're going to do instead is we're going to check everything else, follow every troubleshooting procedure that we possibly can, eliminate every other possible source, saving the CPU for last. But we're going to do that in the next episode in this series because, well, this one's gone on quite long and I'm going to throw the towel in for this week and take a little mental break from this machine. But we are not going to give up on it. We are definitely going to get this TI-99 up because I need to finish out my TI-99 train over there properly. So definitely hang around if you want to see this thing come to fruition. And I want to thank you guys so much for watching today, and I hope to see you in the next episode.